All right, in this edition of our videos, we're going to look at surface area of polyhedrons. We've already been looking at area of 2D shapes, but now we're going to look at polyhedrons. So let's just remember what that means. Polyhedrons, remember, are not 2D shapes, but rather they are 3D shapes. And when you see the word surface area, you see area right in there. So that has something to do with it. But it's really the total surfaces. So since 3D shapes have more than one surface, they're made up of more than one 2D shape, we have to find the area of all of the surfaces. So let's take a look. All right, so we're going to look at this first polyhedron, and even though on this polyhedron we only see 3 of the surfaces, or what I call faces, I'm hoping that we remember that there's actually 3 more. So let's just look at it. We have a top, which I'm outlining in green, and because there's a top, there is a bottom, so I'm just going to record this over here. There is a, let's call this a front face, and because there's a front face, there has to be a back face, and then we're going to call this last one the side, okay, and because there's this side, there's going to be another side, so we'll just call this the sides, okay. So on a cube, on a rectangular prism as well, there's going to be 6 faces, and our job is to find the total area. So because of that, what we're really doing is we're finding the area of each face, and then we are going to add them together. So if I look at the top and bottom, now the nice thing with this one is this one happens to be made up of grids. So because it's made up of grids, I don't really have to do anything with formulas. I can simply count. I can see that the top has 1, 2, 3, 4, 5, 6, 7, 8, 9 units squared, and again I don't know what kind of units they are, but because that's the top, I have to multiply it by 2 to get the top and the bottom. So I know that the top and bottom are 18 units squared, and that's without doing that much work. When I get to my blue, which in this case is going to be our front back, it's the same idea. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a cube, so we're going to get 9 every time, but just to show us, we get 9 units. Oops, and that's the front. And again, to get the back, I'm going to multiply it by 2, and that gives me my front slash back. So that one's 18 as well. And the side, that one's going to be 18 as well. But again, just so we can see, I'm getting 9 again over here. And that is the side 1 equals 9. And I'm going to multiply that by 2 because there's 2 of them, and I get 18 again. So in this case, the surface area is the total area of all of the faces. And so what I'm going to do is I am going to add these together. And if I add 18 plus 18 plus 18, I get 54 units squared. Because it's still area, it still gets units squared. Now you might be thinking, well, why would we need surface area? Well, surface area is all about, again, exactly what it's saying, the area of all the surfaces combined. So we talked in class about things that you might have to find in real life. This could be total cardboard. It could be a box company that's making boxes, and it wants to know how much cardboard it needs in all to make that box. It could be wrapping paper, because wrapping paper goes around the whole box. Okay, so that we're not talking about the stuff inside, the amount of space inside. We're talking about the amount of space on the outside of this 3D shape. So now let's look at one that does not involve grids. All right, so now we see another example. This time we see a rectangular prism. The dimensions are given to us, and as we know about 3D shapes, not only do you need, in the case of a rectangle, do you need the length and the width, but you also need height. That's what makes it a 3D shape. So in this case, you can also see through the box, and you can see the opposite face for every face that is sort of right in front of you. So again, I'm going to look at this, and again, I'm realizing that I'm going to do this in colors again, that I have a top. Now again, because I have a top, I also have a bottom, and I can actually see it here. And I'm going to start with that. And in this case, because there's no grid lines, I can't simply count. So I have to find another method for finding the area of these 2 faces, and I'm going to use a formula. And I remember that my formula for a rectangle, because that's what each of the faces are, is A equals LW. And so I have to make sure I get the correct dimensions, okay? So this is really important. So when I'm looking at this one, again, the bottom one that's in red, I'm noticing that it's a 7 by 4. So even though there's a 2 over there, I'm not going to use it right now. So I have a 7 by 4. And I know that 7 times 4 is 28. But again, because there's a top and a bottom, I'm going to multiply this by 2. And I get 56. Now, some people will find the 3 different surfaces, add those up, and then multiply their answer by 2. You can do that as well. I just like to kind of do it right in the beginning. So I know now I have my top and I have my bottom. So now I'm going to move on, and I'm going to move to a different set of faces. And I'm going to choose to move to what you're going to see in blue. Okay? And I actually might even, I think I'm going to erase what I already had just so it's not confusing. And I am going to start again, and I'm going to go with what I see in blue, which I'm going to call this my front. And I know if there's a front, there's a back. And the back is right back here, the other thing that you see that I'm outlining in blue right now. Now again, it's important to use the right dimensions. Again, it's a rectangle, so I can use the exact same formula I used before, but my dimensions are going to be different because now, if you notice, it's 7 is the length, but 2 is the width. Now it's really the height of the box, but when we're just looking at that rectangle, it's the width of the box. So I'm going to be using 7 times 2, and I get 14. And again, because there's a front, there is a back, so I'm going to multiply that by 2, and I get 28 centimeters squared. So now I have 2 numbers that I'm going to need, but I need a third one because I'm not done yet. What I have not used yet are these ends or these sides. It depends on what you want to call them. And I'm going to outline those in yellow, and I'm just going to get rid of my blue so that we don't get confused. I'm going to go back and put my yellows in. Okay, and again, you can call these whatever you want. Again, sometimes I call them sides, sometimes I call them ends, but they're the last 2 sort of surfaces that match up. And again, they're still rectangles. They look kind of squarish from here, but they're rectangles, and so it's going to be A equals LW again. And again, I have to make sure I use the correct dimensions. If I look at it, it's 4 by 2. So it's a 4 by 2, giving me an area of 8, and there are 2, so I'm going to multiply that by 2, and I get 16 for my final set of numbers. Now, what I want to explain to you, and this is very important, and it's a really important tip, is that when you have 3 completely different dimensions, in this case you have a 7, you have a 4, and you have a 2, then when you do your 3 different problems, they should be all different. So if you find yourself like doing the same problem again, like let's say you did 7 times 4 and then you find yourself doing 7 times 4 again, then you did something wrong, because if there's 3 different dimensions, there should be 3 different problems. The only time you'll have the same problem is when 2 of the dimensions happen to be the same, okay? Now, once I have this, again, to get my total surface area, I'm going to add them up. And so in this case, I'm going to come here, set it up vertically, and I know that 6 plus 8 is 14, plus another 6 is 20, and I get 2 plus 5 is 7, plus 2 is 9, and 1 is 10. So I end up with 100, and again, it's centimeters squared because it is still area, okay? And so that's how you find surface area. Now, we've done a cube and we've done a rectangular prism. So just to kind of end it out, I'm just going to do one more thing so that you can see it. The last example I'm going to do is now looking at a square pyramid. I know it's a square pyramid because if you look at the base of it, it's a 6 by 6 inch. It kind of looks like a rhombus or even a parallelogram, which it is a parallelogram, but it is actually a square because it's 6 by 6. It's just the way the angle is. And then you're going to notice there's one other dimension in here, and that is this 8, which is giving you the height. Okay, so when I'm finding the surface area of this, what I want to remember is that a square pyramid is made up of a square base, but it's also made up of 4 triangles. Those triangles are each coming off the base, and they are congruent. So I am going to just say that I've got my triangles and I have my square, but I'm going to remind myself that there's 4 of these triangles. And because they're congruent, I can just multiply by 4. So if I'm doing surface area, if I wanted to cover this was a box and I wanted to wrap it with wrapping paper, then I would look at my square base first. And again, I'm going to use a formula that works for squares, which is A equals LW. And I just need to make sure that I'm using the right dimensions, and in this case I'm going to use the 6 times the 6, and I get 36 really quickly. And now I move over to my triangles. So again, you have to be careful. Remember, this is one, I'm going to outline this in blue. So I've got one of my triangles here in blue. And so again, I remember, all right, if I'm going to work with triangles, I need 1/2 BH. And so I have to fill in. So I look at my base. Well, it's sitting on this line here, which is blue, but it goes with that 6 inches, which was one of the sides of my square. So my base is 6. My height, remember, is that thing that's in the middle. It's that 8 going straight up. So I'm just going to plug that height in. Now remember, with triangles, I have a couple options. I can either do 6 times 8 is 48 and half it. I could half the 6 and do 3 times 8, or I could half the 8 and get 4 times 6. Either way, you'll get the same answer, which in this case is half of 48, which is 24. Now remember, that's just one triangle. So because I have 4 of them, I need to multiply this by 4. And I'm getting 96. So the triangles together are 96. The square is 36. And so my last step is just to take these two and add them up. And when I do, I get 132, and it's still inches squared because it's area, and that would be how much wrapping paper I need to have in order to cover this entire box. So that gives you a nice little lesson on surface area, showing you 3 different shapes, both with grids and without. The key to success with surface area is it's not usually that hard, but you must organize your work so we can follow it. All right, enjoy.